on the basis of electronic configuration. Let's solve. Use your brain power. The symbols used for the shells are KL. Yes, symbols used for the shell are K, L, M and N. Okay. The symbol and ordinal number of the innermost shell is, the symbol is K. Yes, ordinal number is 1 and its maximum capacity is 2. So write the symbol of electron distribution in shell of fluorine as the fluorine atomic number is 9. Okay, that means there are 9 electrons. So see its electronic configuration, 2 electrons in first shell and remaining 7 electrons in the L shell. Okay, which is the outermost shell of fluorine atom? Yes, as we know, the 7 electrons in an outermost shell, that is L shell. L shell is the outermost shell of fluorine. Which is the outermost shell of sodium atom? Yes, sodium atom have electronic configuration. Firstly, the atomic number is 11. Yes, 11 electrons. So its electronic configuration becomes 281. Okay, so it have the M shell. Yes, M shell is the outermost shell. Which is the outermost shell of hydrogen atom? Yes, hydrogen atom have only one electron. Okay, and it is in M K shell. Okay, so K shell is the first shell and the outermost shell of an hydrogen atom. Let's see about the valencies. Okay, valencies means number of chemical bonds formed by an atom. Generally, valencies of an element remains constant in its atom forms chemical bonds by using electron of its outermost shell. Valency of an atom is determined by the configuration of its outermost shell. Therefore, the outermost shell is called valence shell. Yes, most important point is the outermost shell is called a valence shell and the electrons present in valence shell are called a valence electrons. We can determine valencies of elements by using molecular formula. Let's see how it is. Yes, hydrochloric acid HCl split the element H and Cl. Let's see the atoms of the hydrogen. That is 1. Write down below the hydrogen. Chlorine's atoms are also 1. Write down below chlorine and then cross it. Okay. From this you can understand hydrogen's valency is 1 and chlorine's valency is 1. Okay. So second, H2O water. Split the elements hydrogen H, oxygen O. Then see the molecular formula. Here 2 atoms of hydrogen. So write down below hydrogen and 1 atom of oxygen. Write down below oxygen. Okay, and then cross it. So by this you can understand valency of hydrogen is 1 and oxygen's valency is 2. Next example, NH3 ammonia. Yes, nitrogen. Yes, nitrogen, 1 atom of nitrogen, hydrogen's 3 atoms. By crossing it you can understand nitrogen valency is 3 and hydrogen valency is 1. Like this we can find out the valencies of other elements also. Let's see about the valencies. Okay, valency are depend on the valence electrons present in the valence shell. Okay, so as the inert gases like helium, neon, argon, their duplet and octets are already completed. Okay, so their valency is 0. Let's see how it is. In the helium atom there are 2 electrons. So 2 electrons are in K shell. K shell's capacity is only 2 and hence its electron duplet is get completed. About neon. Yes, neon's atomic number is 10. That means its electronic configuration is 2, 8 and outermost shell is L. L's capacity is 8. Okay, every atom tries to complete its octet and satisfy, but here neon's octet is already completed. Next, about the argon. Yes, argon's atomic number is 18. Okay, so in the last shell there are 8 electrons, but we already know M shell have capacity of 18 electrons. Okay, but every atom tries to complete its octet, and hence the argon's octet is get fulfilled. Inert gases, yes, inert gases valency is 0, and it is also called as the noble gases. Inert gases that does not participate in any chemical reactions, that does not combine to any other element. Okay, the electronic configuration of elements other than inert gases show that they do not have electron octet. Okay, or their electron octet are incomplete. Regarding hydrogen, it can be said that its electron duplet is incomplete. Observe the figure in which hydrogen have only one electron. To complete its duplet, it requires one electron. So, its valency is 1. Oxygen. See, oxygen atomic number is 8. 8 electrons are there. In outermost shell, there are 6 electrons. So, to complete its octet, it requires 2 electrons. So, valency of oxygen is 2. Okay, and carbon. Carbons have 6 atomic number, that means 6 electrons. In outermost shell, there are 4 electrons. Its valency is 4. Now about nitrogen. Yes, nitrogen's atomic number is 7 electrons, and in outermost shell there are 5 electrons. It requires 3 electrons to complete its octet, so its valency is 3. By this table you can find out the valencies of elements, yes, by its electronic configuration. Let's about hydrogen. Hydrogen's valence electron are 1, so it requires one more electron to complete its duplet, so there is 1 valency. Okay, helium. Helium, yes, valence electrons are 2. Here, as their duplet is completed, their valency is 0. Now about lithium. Yes, valence electrons are 1, so its valency is 1. After that, beryllium. Yes, valence electrons are 2, so valency is 2. Now about the carbon. Carbon's valence electrons are 4, and hence valency is 4. Yes, if the number of valence electrons are less than or equal to 4, the valency remains as it is. If valence electrons are 2, then valency is 2 also. Okay, so next, nitrogen's valence electrons are 5, so valency is 8 minus 5, that is equal to 3. Okay, when the valencies are 4 or greater than 4, that time we subtract the valence electrons from 8 and we will get the valency. Like this, find out other elements' valencies. Use your brain power. See, the atomic number. Atomic number means the number of protons present in nucleus of an atom and the element. Okay, it is called as the atomic number. Here, actually, proton number and electron number are same. So, we can take any one, proton number or electron number, as a atomic number. Second, we have to complete this chart. And this, the atomic numbers are given and we have to find out the electronic, yes, the number of electrons in the outermost shell. Okay, element, hydrogen 1, so in outermost shell there are 1 electron. Okay, carbon, yes, electronic configuration of carbon is 2 4, so in outermost shell there are 4 electrons. Sodium 11, so electronic configuration is 2 8 1, that's why, yes, 1 atom is in outermost shell. And chlorine 17, so its electronic configuration is 2 8 and 7. So valence electrons are 7. Nitrogen 7. Electronic configuration is 2 5. So the valence electrons are 5. Okay, so in next table their elements are given as well as their number of electrons are given. We have to find out electronic configuration, number of valence electrons and valency. So as lithium there are 3 electrons, that means electronic configuration is 2 1. Valence electrons are 1, that's why valency is 1. Carbon atomic number, that electrons are 6. Yes, electronic configuration is 2 4 and valence electrons are 4, therefore valency is 4, that is 8 minus 4 or 4 as it is. Magnesium, yes, number of electrons are 12, electronic configuration 282 and the number of valence electrons are 2, valency is 2. So if the valence electrons are 4 or less than 4, we are taking valency, that valence electron as it is as valency. Oxygen 8, electronic configuration is 2 6. Yes, valence, number of valence electrons are 6. Okay, and if we subtract 8 minus 6, there are 2 valency of the oxygen. Okay, why are the atomic numbers and atomic mass numbers always in whole number? Yes, atomic numbers and atomic mass numbers contain number of protons. Yes, atomic numbers contains number of protons and atomic mass number contains total number of protons plus neutrons in a nucleus. Okay, so as protons, neutrons as well as electrons are in whole number, so yes, the atomic numbers and atomic mass numbers are always in whole number. Here given sulfur contains 16 protons and 16 neutrons. What would be its atomic number and atomic mass number? We know that atomic number, that is Z, is the number of protons or electrons. So here protons are 16, so atomic number is 16, whereas yes, atomic mass number is the number of protons and neutrons. So here protons are 16 and neutrons are 16. It becomes 32. Okay, so atomic mass number of sulfur is 32. In the nature, some elements have the same atomic number but different mass number. Such atoms of the same element having different mass number are called isotopes. Okay? So, in short, we can write the elements having same atomic number, yes, but different atomic mass number are called as the isotopes. See here examples. There are 3 isotopes of the carbon, C12, C13 and C14. We can write it in the form of yes, atomic mass number also, C12, C13 and C14. Its as its atomic number is remains constant, C. Okay, these isotopes have some same protons number but different neutron number. Let's see the isotopes. Carbons, 3 isotopes are given. Here mass number is 12, C12's mass number is 12. So proton number is 6, but there is a different neutron numbers, that means 12 minus 6. Here done, 12 minus 6, it becomes 6. Now 13 is the atomic mass number and 13 minus proton number are 6, so it becomes 13 minus 6, 7. Next the 14, atomic mass number is 14, 14 minus 6, it becomes 8. Okay, so from this we can find out there are different neutron numbers. Isotopes, proton number and neutron number we have to find out. Okay, 1H1. Yes, actually this on the base there is atomic number, Z is given, that means proton number, and here on the upside their atomic mass number is given, that is proton plus neutron. Okay, so proton number, yes, proton number is 1 and we have to find out neutron number. If we subtract 1 minus 1, there is 0, and we already know hydrogen have no proton. In the isotope, second isotope, yes, there are 1 proton and 1 neutron. Okay, so atomic number is 1, and find out atomic mass number. 1 plus 1, it becomes 2. Therefore, second isotope 1H2. Now 1 proton and 2 neutron, that means atomic mass number is 3. Therefore 1H3. This is the third isotope of hydrogen. Second, here Cl. Do correction here. Chlorine have 17 atomic number. Okay, chlorine, there is 17 atomic number and mass number is 35. So proton number is 17. Okay, and neutron number is 35 minus 17, it becomes 18. Okay, second 17 Cl37. Okay, proton number are 17 and neutron number are 37 minus 17, it becomes 20.